The world is filled with mysteries and paradoxes that continue to confound and amaze both scientists and the general public. The Fermi paradox, the information paradox, and the grandfather paradox are three of the most well-known and thought-provoking paradoxes known to mankind. Each of these paradoxes provides a distinct and difficult challenge to our understanding of the cosmos and our place within it. Paradoxes such as the presence of extraterrestrial life, the nature of information in black holes, and the potential of time travel have fascinated scientists, philosophers, and science fiction authors for decades. Join us as we delve into the fascinating and mind-bending world of these three paradoxes as we investigate their origins, ramifications, and ongoing controversies. The Fermi paradox is one of the most intriguing riddles in scientific study. For decades, this contradiction has kept scientists and academics awake at night. Fermi's paradox is named after the eminent scientist Enrico Fermi, who is credited with its discovery. The Fermi paradox is the seeming contradiction between the high possibility that alien civilizations exist and the absence of proof or interaction with such civilizations. Why haven't we detected any significant signals of extraterrestrial life if there are so many potentially habitable planets in our galaxy? This is one of the most intriguing concerns raised by the Fermi paradox. This inquiry generates more inquiries, such as, are we alone in the universe? Why haven't we been contacted if not? Have we been searching in the proper locations? Are our detection methods adequate? There are no other sentient civilizations in the universe, is one possible solution to the Fermi paradox. The rare Earth hypothesis proposes that the Earth is unique in the universe, and that the conditions that led to the advent of sentient life on Earth are highly rare. Recent discoveries of exoplanets that are comparable to Earth in size, composition, and distance from their host star have cast doubt on this theory. Another possibility is that other civilizations have perished before we had the opportunity to discover them. This concept is referred to as the Great Filter. The Great Filter posits that there is a cataclysmic event or obstacle that all civilizations must surmount in order to evolve, and that the majority of civilizations fail to do so. This includes environmental calamities, war, pandemics, and technology developments that result in self-destruction. If the Great Filter hypothesis is true, then our survival as a civilization is in jeopardy if we approach the filter. The Fermi paradox also raises problems regarding our detection methods. Are we searching in the proper locations and employing the proper methods? Conventionally, the search for extraterrestrial intelligence, SETI, has centered on the detection of radio waves and other electromagnetic communications. But this strategy assumes that other civilizations communicate in the same manner that we do. It is possible that we are unaware of different communication methods or technologies. The likelihood of a Type 3 society is another aspect of the Fermi paradox to ponder. A Type 3 civilization is one that has mastered the energy of a whole galaxy. Consequently, we would be able to detect their presence with ease. Yet, no such signals or indications of their existence have been identified. This means that we are either not searching in the appropriate regions, or that Category 3 civilizations are simply unattainable. The information paradox is one of the most baffling and perplexing dilemmas in astrophysics. It challenges our knowledge of the cosmos and fundamental physical rules. Simply expressed, the information paradox relates to the notion that information cannot be destroyed, yet it appears to be irretrievably lost when it falls into a black hole. When we analyze what happens to information that enters a black hole, the information dilemma develops. The rules of thermodynamics state that information cannot be destroyed. This idea is referred to as information conservation. Yet, it appears that when matter falls into a black hole, the information it carries is gone forever. This contradicts the notion of information conservation and poses a challenge to our understanding of the universe. Yet, how does the information paradox defy physical laws? The information paradox contradicts the second law of thermodynamics, according to which the entropy, or disorder, of a closed system constantly grows with time. As additional matter falls into a black hole, the entropy should grow. Nonetheless, according to the principle of conservation of information, the information contained in that object should be kept. This contradictory statement challenges our knowledge of thermodynamics and information theory. Let's examine the function of black holes in the information paradox. Due to their status as the most severe forms of gravity in the cosmos, black holes are the principal focus of the information paradox. A black hole's gravitational pull is so powerful that it can imprison light, rendering it invisible to our telescopes. It is believed that as matter falls into a black hole, it is compressed into a singularity of infinite density. This makes it impossible to obtain the information contained in that object. But is it possible to preserve information within a black hole? The dispute among physicists as to whether information can be maintained within a black hole is extensive. The concept of Hawking radiation is one potential remedy. Stephen Hawking asserts that black holes generate a sort of radiation that causes them to gradually lose mass and eventually evaporate. It is believed that this radiation contains information about the materials that entered the black hole, therefore preserving it. There have been numerous proposed answers to the information dilemma, but none have been conclusively demonstrated. One solution is the concept of complementarity, which proposes that information can concurrently exist in two distinct forms. The holographic principle proposes that all information stored inside a region of space can be encoded on the region's perimeter. The most widely recognized solution is the concept of Hawking radiation, which argues that information is encoded in the radiation emitted by a black hole, rather than being annihilated. Traveling through time is one of the most intriguing and hotly contested issues in physics and philosophy. People's imaginations have been captivated for generations by the notion of time travel, either to the past or to the future. Scientists and philosophers have been perplexed by a distinctive difficulty associated with the concept of time travel. Let's delve deeper into the grandfather paradox and investigate its consequences and potential resolutions for this mind-boggling contradiction. The grandfather paradox is a scenario that arises hypothetically in the context of time travel. Suppose you develop a time machine and use it to travel back in time to meet your grandfather when he was young. You mistakenly kill him before he has children, therefore preventing your birth. If you had never been born, you would not have been able to travel back in time and kill your grandfather, meaning he would still be alive and you would not exist. This results in a paradoxical cycle that appears unsolvable. The grandfather paradox has significant consequences for the theory of time travel. If time travel is conceivable, the past is not immutable and can be altered. Yet, the paradox indicates that altering the past might result in inconsistencies and contradictions. It raises the question of whether or not time travel is actually conceivable or merely a fabrication of our minds. Many solutions to the grandfather paradox have been offered. One answer is the concept of the multiverse, which proposes that once a choice is made, the universe splits into several parallel universes. In this scenario, if you traveled back in time and killed your grandfather, you would not do so in your own universe, but in a parallel one. So, your own existence would not be altered. The concept of predestination is a further answer to the grandfather paradox. This implies that the past cannot be altered, and any attempt to do so would be fruitless. In this situation, your effort to murder your grandfather would fail, either owing to an unanticipated circumstance or predestination. But is the grandfather paradox a genuine issue or merely an intellectual exercise? The grandfather paradox is a classic thought experiment intended to investigate the consequences of time travel. Yet scientists and philosophers are still debating whether this is a real problem or a hypothetical possibility. Some think that it is a genuine issue that must be resolved before time travel may become a reality. Others believe that it is merely an intellectual exercise with no effect on the idea of time travel. The Fermi paradox, the information paradox, and the grandfather paradox all provide intriguing insights into the mysteries of the cosmos and the nature of time. These paradoxes drive us to reassess our presumptions and our understanding of the cosmos. These paradoxes remain unanswered despite the efforts of scientists and philosophers, leaving us with more questions than answers. In addition, they serve as reminders of the vastness of the universe and the limitations of human knowledge. As we continue to investigate the mysteries of the cosmos, it is essential to maintain an open mind and welcome the unknown. Perhaps one day we will discover the answers to these paradoxes. But until then, all we can do is marvel at the universe's complexity and wonder. Let us know what you think about these three mind-boggling paradoxes in the comments section below.